Hello class, today we're going to talk about adding fractions, and we're going to start back with the basics from elementary school. So what does it mean to add? Well, obviously when we add two numbers, it means to take two separate groups of objects and count them together as one group. So back in elementary school, if we were doing 3 apples plus 2 apples, we've got a group of 3, we've got a group of 2. We're going to go ahead and count those two groups as a single group, and of course, what would be in that group? There would be 5 apples in total. Originally, we had 1, 2, 3, and then 4, 5 from the other group, making us have one group of 5 apples. Obviously, that's not so bad. And we also know that when we're adding, we need to kind of have some similarity between the objects. Obviously, if you tried to do 3 apples plus 2 bananas, well, what does that equal? Does it equal 5 banapples? Some sort of weird hybrid of apples and bananas? No, it doesn't. These objects are not the same, so we can't just count them up and say, well, I've got 5 of them, because 5 what? They're not the same. We can't say that there's some sort of weird hybrid of objects. So, of course, we know that when we are adding, our objects have to be the same as each other in order for us to be able to count them up. No one wants to end up with banapples, okay? So what does that have to do with fractions? Well, fractions have two parts, the top and the bottom. And in a fraction, the denominator, which is the bottom number, tells you the size and shape of the parts of your whole. So if I have a fraction like 1/3 with a 3 on the bottom, the 3 on the bottom tells me to take one whole object. In this case, one whole object is one circle, and split it up into 3 equal parts. Each of those parts is shaped like this shape here. That is our shape of thirds. The top of that fraction tells me how many parts I have. So I've got 1 shaded in there out of my 3 total parts. So 1 out of 3, or 1/3, is this drawing here. Similarly, if the bottom of my fraction is a 5, it means take my one whole circle and split it up into 5 equal parts. And obviously those parts have a different shape than our thirds, because they're smaller, right? Obviously this shape here is different than this shape here. And again, in this situation, we'd have one part shaded in, so the top of our fraction would be 1. So the bottom tells us the shape of the parts, because it tells us how many parts are in one whole. The top tells us how many parts we actually have. Now, since we know we can only add things that are the same as each other, and the bottom tells us the shape of the parts, when we are adding fractions, the denominator, or bottom, has to be the same so that we are counting up the same shape of our parts. Once the bottoms are the same, we can just count up how many parts we have, and that means that we're going to add the numerators. So if we have something like 1/5 plus 1/5, both of these are shaped the same. Both of them are shaped as a fifth, and we can just count them up. There's 1 here, 2 here. That gives us 1, 2 in our answer total if we add those together. We could say our answer is 2/5. How do we get that? Well, we're going to go ahead and add the numerators, 1 plus 1. And on the bottom, we've got a 5, and that's because the shape of the pieces doesn't change by counting them together. We're just moving this piece there, and this piece there, and we're saying that together as a single group, they are a section that is 2 out of 5 of a whole. Bottom doesn't change because the shape of these parts that we're counting doesn't change. So let's go ahead and look at our generalized steps for how to do this. We're going to use drawings to assist us with understanding this today, but obviously our normal steps here do not require drawings to work. So the first thing we have to do is we have to have the bottoms be the same, and we call those common denominators. The denominators are in common with each other, they are the same. And if we don't already have that, we're going to need to create equivalent fractions with that common denominator. First thing we have to do there is find what the common denominator is, and the common denominator will always be the lowest common multiple of the existing denominators. So we'll list out a bunch of multiples of our denominators. We'll select the lowest one that is in both lists. Next, we're going to need to make our fractions be equivalent with those common denominators. And to make an equivalent fraction, you have to multiply both the top and the bottom of our fraction by the same number. And we're going to choose that number to make the bottom be the common denominator. Only after we have the numbers on the bottom of our two fractions be the same, we can continue onwards. After they're the same, we just add or subtract the numerators, the tops. We're going to keep the common denominator on the bottom, and we'll reduce or simplify our answer into our simplest or lowest form. So let's take a look at some examples here. We'll do 3 quick and easy ones. Let's start with 1/2 plus 1/2. You'll notice that as step 1, the bottoms of these fractions are already common. And that's good because it means that we are adding the same shapes to each other. So obviously we've got one section here shaded in out of a whole that is made of 2 sections in total. And over here we've got one section shaded in out of a whole that is made of 2 sections in total. Those sections are the same size and shape as each other. You know, these 2D shapes are the same. They're just reverse images of each other. So we'll go ahead and put them together in our answer. We can just count them up. And we can see that we have 2 sections filled in into our whole out of a whole made of 2 sections. How do we get that from our symbolic work? Well, we're going to go ahead and engage in step 2, which is add the tops. We're going to do 1 plus 1 on the top. Step 3 is to keep the bottom. The bottom number was 2. We're going to keep it as 2. 1 plus 1 on the top is 2. We're going to keep the bottom of 2. And then as step 4, we're going to reduce or simplify. So I can divide both of these numbers by 2. I get 1 out of 1, which is just 1. If I look at my drawing, that makes sense because I've got one whole circle filled in my sum. Okay, so make the bottoms common. In this case, they already were, which means we have the same shapes as each other. We're going to add the tops, put those pieces together. We're going to keep the bottom. The bottom tells us the shape. Putting pieces together does not change their shapes. And then we'll reduce to a simplest answer. That one's pretty easy. Let's go ahead and take a look at a little bit harder one here. In example B, we've got 2/3 plus 5/6. So this drawing here represents 2 sections out of a whole split into 3 sections. This one represents 5 sections out of a whole split into 6 sections. And you can see our problem here. This piece here is not the same shape as this piece here, for example. So we can't just count them up and say, oh, I got 1, 2, 3. I can't do that. They're not the same size and shape. I don't want banapples. So I'm going to need to go ahead and engage in step 1, which is to make a common denominator. I'm just going to put CD for common denominator. So let's think about multiples of our 2 denominators that we already have. We have denominator 3, and we got denominator 6. Multiples are just counting by that number. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and so on and so forth. Those are multiples of 3. So you could do multiples of 6, same idea. 6 times 1 is 6, 6 times 2 is 12, and so on and so forth all the way through. If I look for the first number that is in both of those lists, it's obviously 6. And so I'm going to make equivalent fractions that have a denominator of 6. So what do I do to 3 to make it into a 6? I'm going to need to multiply it by 2. And remember, when I'm making equivalent fractions, I always have to do the same thing to the top and bottom of the fraction. So since I multiplied the bottom by 3, I also have to multiply, by 2. I also have to multiply the top by 2. 2 times 2 on the top is 4, and 3 times 2 on the bottom is 6. For my other fraction, what do I do to 6 to make it into 6? Well, I just multiply it by 1 or leave it alone. 5 times 1 on the top is 5, and 6 times 1 on the bottom is 6, and I am still adding these. We can now see that these bottoms are common, or the same. So what have we really done here? Well, what we've done is we've taken those same sections or shapes and we've just split them up. So we've cut each of these ones into 2 equal parts. And we said, well, the same shaded area could be represented as 4 sections out of 6. It's the same amount of shading in that yellow diagram, we've just made it into sections of 6 instead of sections of 3, as they originally were. Now our sections are the same size as each other. This section here is obviously the same size as this section here, and so we can go ahead and count them up. I have 1, 2, 3, 4 sections from the yellow one, plus another 5, 6, 7, 8, 9 sections from the blue one. And so if I rearrange those and fill them into some circles, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 sections in total as one group. So what does that look like as far as our symbolic work? Well, we're done step 1, which is to make that common denominator. We have our bottoms the same number. So we're going to move on to step 2, which is to add the tops. Obviously, we're going to do 4 plus 5 as our top numbers. Step 3 is to keep the bottom. 6 is still 6. And we're going to end up with, well, 4 plus 5 is 9, and the bottom is 6. And obviously that's what we ended up with here as well. 9 sections, where each section is 1 out of 6 parts of a whole. Now, we do need to do step 4 here. Step 4 is to reduce. If I look at both 9 and 6, both of them can divide by 3 to reduce it down. 9 divided by 3 is 3, and 6 divided by 3 is 2. If I look at my new fraction of 3 over 2, I can't simplify that any further. There are no further numbers that divide into both 3 and 2. So that's going to be my simplest improper fraction. I could, however, convert it to a mixed number. 2 goes into 3 one time with a remainder of 1. And if I look at my drawing, I can see that I have one whole circle filled in, and then an extra half of a circle filled in as well. So that's my 1 and 1/2 as a mixed number. And obviously I have 9 out of 6 as my improper fraction before it was simplified. 9 sections, and each section is 1/6. Let's do one more of those. Let's take a look at this one here. I've got 1/2, which is this diagram here, added to 3/5. And that would be this guy here. 3 sections out of a whole made of 5 sections. Again, we can see the problem here is that our bottoms are not the same. Obviously, 2 and 5 are not the same number. And why that's a problem is that this section and this section are obviously not the same shape. So I can't just count them up as they are. I need to do step 1, which is to make a common denominator. So let's think about multiples of 2 and multiples of 5 to find our lowest common denominator. Multiples of 2 are 2, 4, 6, 8, 10, 12, so on and so forth. Multiples of 5 are 5, 10, 15, and our lowest number that is in both lists is 10. So what do I do to 2 to make it into 10? I'm going to multiply it by 5. What I do to the bottom, I also have to do the top. What do I do to 5 to make it into 10? I need to multiply it by 2. And what I do at the bottom of that fraction, I have to do the top. 5 times 1 is 5, and 2 times 5 is 10. 3 times 2 is 6, and 5 times 2 is 10. Notice that, again, we now have our common numbers on the bottom. Let's use black for that. Let's go ahead then and do step 2, which is to add the tops. Our top numbers are 5 and 6. Step 3 is to leave the bottom alone, or keep the bottom. Bottom is 10. 5 plus 6 is 11, and our bottom is 10. 11 is a prime number, so in this case there is no reduction possible. It will not divide by anything except itself. But I could make it into a mixed number. 10 goes into 11, one time with one remainder. So I could say either the improper fraction 11/10 or the mixed number 1 and 1/10. Again, if we think about what actually happened here, we took our amount of shading here for 1/2, and we just made it into sections that are 1/10. There are 10 total sections in the circle now, and we still have the same amount of area shaded in. Same thing with our 3/5. We just made it into sections, 10 sections total in that circle. The shading area has not changed. We've just changed how many parts and how many sections we have. We then look, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sections shaded in total. And of course, that was the numerator of our answer there. And if we fill that into circles, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 total sections filled in. Or we could say one whole circle and an extra 1 out of 10 in the second circle. And that's obviously our mixed number answer. So I hope that this has helped you remember and recall how we add fractions.